Well, so we're having a little bit of problem with Erich's link call from Zurich, Switzerland. So they're going to work on that. So in the interim, we'll just kind of keep going. So we're going to start off with Priyank, who is with what group are you with?
F12 debugger team in DevDev.
Okay, perfect. So we'll just let Priyank take it away. Is your mic on?
Yeah, can you?
Yeah.
Yep. Okay, so hi everyone. I'm Priyank and I'm from F12 debugger team. So if you have been using F12 debugger for IE, we create F12 for IE. So for TypeScript, we recently worked with the TypeScript team, and we created a specification for mapping the local variables in the source maps, and mapping the local variables using source maps. So if you're using TypeScript for debugging, you could see like for sometimes when we add a watch or something, the expression that the TypeScript gives is not exactly the one that compiles, and that's one that's actually running on the JavaScript engine at the back end. So when you evaluate that expression, it would be something like this gets converted into underscore this if it's a lambda expression. So we worked with the TypeScript team, and we created a specification so that we can actually map this to underscore this in a particular scope based on wherever the debugger is currently broken. So I can show you the demo right now. So this one is like an older version of the source maps. So if I put a breakpoint in the debugger, yep. So if I put a breakpoint here, I can show you like what used to happen before is, for example, let's put a breakpoint here and I refresh this window. So right now this website is using the older version of the source map. So if I hover over this clock face, it would say the clock face is undefined because it's directly evaluating the clock face expression onto the runtime, and there is no clock face runtime expression. But if I look at the compiled JavaScript version of the clock face, it would be clock.clockface. So if I hover over the JavaScript here, if I evaluate clock.clockface, it will say that it's an actual class that's defined in this TypeScript file here. So what we did to fix this problem is we created we create a map for the local variables in a particular scope. So in the source map file that's newly generated, it would be like it would have a scope information, and it would have the map information, local variable information mapped to it. So for example, in this case, it would say that the clock variable is mapped to clock.clockface for this particular scope. Scope would be defined saying from this line to this line here in the JavaScript, and then there would be a parent scope. So in case if it's the parent scope, like this one is enclosed in a parent scope here, then it would say that it's defined from it's enclosed in this to this. So if there is any local variable in the parent scope, then it would also be available to the smaller scope that's enclosed by the parent scope here. So yeah, this is one example. Or for another example would be, if I just press stop here, this is the one that I was talking about. So this, in this case, is the JavaScript runtime. Whenever it evaluates this, it says that it's an object. It's a window object, but actually we know that from the TypeScript code that we can see that this was actually a clock face object. So these are the problems that we face recently when we are trying to debug the TypeScript using the current version of the source map. So to fix this, I'll switch over to the website which is using the another version of the source maps. It's exactly the same website. The only difference is this one is using the another version of the source map, so it has the scope variable information encoded in the source map. The encoding is the same that is used for these the regular TypeScript compiler to encode these line mappings. So if I in this one, if I go to, if I put a breakpoint here, let's just put a break. Oops. Yeah, and if I refresh the window, yep. So you can see the clock is actually defined. Now we actually get the mapping information of at this particular line position, saying that we are currently broken into the particular scope at line 19 and column 13. So at that particular scope, we have the information about the local variable, and we see that the clock phase expression should be actually mapped to clock.clock phase. So we evaluate that on the runtime and get the value from this. So you can actually see the correct value instead of saying it's undefined. Another thing we do is we actually show this as like a red dot near the saying that it's a source map, and if you hover over it, you can actually see the tooltip. See the tooltip. It says like the author name is clock face, but the generated name is clock.clock face. And if I expand this, I can actually edit the values here as well. So if I edit this value here and change it to 2, then it will edit the clock.clockface.url. So you can actually see the result. If I continue, it changed to the different version of the clock face. Same thing goes in the lambda expression where we are using this, for example. This one. So when we are blocking under this, you can now see that this is actually defined as a clock face, not the window object that we were previously seeing in the older version of the source map. So this would be useful. So even if I expand this local variables here, you can actually see that this is mapped to this, and if I toggle the source maps, it would change it to this. And going back, it again, it's like depending on what version, like are you working on the source map mode or the non-source map mode, it would change the variables on the local variables as well. So yeah, so for this, this is not supported right now anywhere other than F12, because we are working on the specification, and I think Ron Buckton from my team, who worked with the TypeScript team for getting this specification done, is also working with the Google team as well, so that this can be like made as a standard, so that it would be used for the other languages as well. And similarly, I think they are also working to trying to push this for the minifiers as well, so you could actually map to the minifier version. But right now, it's only limited to the local variables, and yeah, that's it.
So in Dev 14, does it work the same way?
So I think the Dev 14 Visual Debugger does not have this support, I think.
Okay.
And this one is like the custom F12. I don't think it's released for the dogfooding as well. Okay. But yeah, but it should just work if they read this source map value. So we checked in this change for the our compiler that we use in our branch. I think Ron was working to get this checked in on the TypeScript compiler for on the Git as well. Okay. So it should be. I think it should be available. I need to check with them for whether it's actually available on the net or not. But right now it's supported in F12, and once the dogfooding bits are out, it should be available internally, and then I think it should go with the preview.
That's awesome.
Yeah. Thank you.
Okay, hey, good afternoon. This is Erich. I'm on the call with Joe from the VS Platform team. We're based in Zurich, and we try to become the perfect TS Meetup attendees. We didn't miss anyone so far, no matter how late it is, even if it's 1 a.m. in the morning. So in this short demo, we'd like to show you a little non-conventional use of TypeScript. So we kind of abuse TypeScript to make JavaScript much better. And Joe and I work on Monaco. Monaco provides services for online development. Like, you can develop in the browser. We have services that run in the cloud. And you see Monaco in action when you edit code in OneDrive, in the Azure portal, Ibiza, several playgrounds. Last year we told about how Monaco is 100% implemented in TypeScript, and for some time we were even the largest TypeScript project. But once the other have kind of caught up, we stopped counting. Now we only refactor and we try to reduce our code, right? So we don't care about being large anymore. So a key element of Monaco is the different language experiences we provide. And our flagship language experience is definitely TypeScript. Because as I said, we implemented Monaco in TypeScript, using Monaco as a tool. And TypeScript is written in TypeScript itself and comes with a language service that provides you reference searching, IntelliSense, validation. and so on. And this was a great base for us to build on. But our challenge was the next kind of how can we get other languages in the same league, that we give them not only syntax coloring, but also validation, IntelliSense, go to definition, these kind of features. And a particular hard nut to crack is JavaScript. As we know, it's really hard to do good tooling for JavaScript, and one of the reasons that TypeScript exists is that it's so hard to do that with JavaScript. But it's important for us because Monaco, one use of Monaco is in Azure Websites, and we just counted today and looked into how many files are saved of the different file tabs, and we see 50% of the files that are saved using Monaco and Azure Websites are still JavaScript. So we cannot close our eyes in front of JavaScript. And our idea here was what we can do is, since TypeScript is JavaScript, why don't we try to build powerful JavaScript tooling by leveraging TypeScript? And we not only want to leverage the language infrastructure like the semantic analysis or the syntactical analysis, we also want to leverage the TypeScript community. Right? As we have heard before, now there's a powerful and rich TypeScript community, and one of the contributions the community gives is typings for different JavaScript libraries. In this definitely typed project on GitHub, there is now almost a typing for any JavaScript library. So and our idea was, can we also leverage these community contributions to provide a rich experience for JavaScript developers? Okay, Joe, I see a blue bar over your screen.
That is not intended.
Oh, it's gone. Okay, good. So rather than just talk about it, we prepared kind of demos in the context of Azure website. We build a website, and Joe can show you JavaScript tooling powered by TypeScript in action. So Joe, please take over.
All right. Thanks for the introduction. So yeah, I'm Joe. My 3 words would be programming, cycling, and eating. So we're done with that. I like that many people like eating. That's a good thing. I could hear you guys very well, so you guys can just ask questions and talk to us. I think then we can keep it interactive. I think on my end, I see like a normal screen. So if you guys still see a blue bar.
No, you didn't have a low power indicator. We're just trying to make sure we're still plugged in. We have power.
No, like I didn't have one. No, I'm plugged in.
Okay. We have.
All right. Okay. So what we see here is a little website that runs as the Azure website on the product Windows Azure websites, and like it doesn't do much. It always spits out a random Chuck Norris programming fact. So website started to sleep, I guess. So whenever you refresh, it will show something new. So maybe I do have connectivity issues because I'm not getting something new here. Nevertheless, I can jump right into the code because this is implemented in JavaScript. So we have been talking about TypeScript all day long, but Eric, most projects on this particular product like use JavaScript files. So and because our mission is to build tooling for these guys, we have to pick them. We can't just enforce TypeScript. We can like bait them into it, but we also have to support JavaScript. And so as mentioned, TypeScript, we already leverage scripting does by just. All right, great. So I hope you see a random Chuck Norris fact on the screen.
We do. We do.
All right, good. So I guess this is where I lost you the last time. So for our demo, we have a little website that spits out Chuck Norris programming facts. So whenever you refresh, there's a new fact, and I won't explain how this program was written and what it does. And you can see my other tab is the Monaco IDE, which consists of a server.js file and a bit of index.html files and some client-side JavaScript. And as said, so This is done in JavaScript, just to reflect reality, what happens in the world. And but we are thinking, we already took the TypeScript language of it once to build a good product, which is our TypeScript language support in Monaco. And now we're thinking just, we just do it again. So we have to do less work and just, build upon the things that are already around. So the first thing you can see, all these syntax tokens, they're computed just using TypeScript. Like the TypeScript scanner is actually quite good. There's a lot of talk about TypeScript being slow, but the scanner is actually very, very fast. So that's the easiest. And then like TypeScript comes with a parser. So we can use the parser, and TypeScript is a superset of JavaScript. So we have a very nice problem that we have a parser that understands more from a language that we have to understand, right? Usually it's the other way around. Your parser doesn't understand like 100% of the language. Now we can do more. And it's very easy to declare those things that are extra as errors. So for instance, if I put like a TypeScript thing in here, you will get a warning to tell you, hey, don't use TypeScript when you do JavaScript, right? It's a very comfortable position to be in. And we even we can sell this as a very, very fault-tolerant compiler because this is not JavaScript, but the compiler still accepts it. The other thing also, if you do a syntax error, we can actually give you a squiggle, which is quite good because like this is most of the things. Like if you work with Sublime, this is things that you don't really get. So this is already a big bonus, and we didn't have to do much, right? We just reuse the TypeScript code that is already there without doing any special tricks. In the same league goes things like outline. So we already saw this in the Roslyn demo. So we can navigate code, and we can also navigate functions that are inside functions. As you can see here, it's a stream function, and there's a function inside that function. So that is all nice. And similar to this is, like if my code is not very nicely written, I can just say format code, and now it looks good again. So also this TypeScript for free. So these are like already big IDE features, right? You get code navigation, you get syntax validation, you get formatting, and that's all for free. So that's already quite good. Now the thing is, most JavaScript developers, they work with JSON. So on top of the AST, you have special rules. And so we also added some of those, and we could integrate them in the nice way because we run the language service here. So for instance, if we say, like, you should not use the double equals, but the triple equality, you can configure this here, and then you see a warning will show up. Very similar is the use of undeclared variables. So I can say undeclared variables is supposed to be an error. And now you will see on the left-hand side, like process and DNA, which is very typical Node.js things, they become a problem. Similar, there's many other things like missing semicolons, and if you do a new on a lowercase function, all these things that JavaScript developers are used to. So I can fix these errors by just saying this is good. And the typical JSON user will do this. So we'll put a comment on top, and then he says global process and DNA. And basically you have to repeat that in every file. So this makes like the error go away, and it sort of tells the tooling that there's a thing called process, even though you cannot find it. That's not optimal. And we already heard that there's this big repository of DTS files. So we allow people to just add references to DTS files in the same way you would do it in TypeScript. So prior to this demo, I have checked out a few DTS files like jQuery, Node, and require, and I can just add this thing. And then you can see the process is not an error anymore. And also for process, I can know there's like an end variable on it. Or if I hover over DName, I can know that DName is a string. So this is already good. This is also something you could relatively for free. But then, like, now let's go a little bit more advanced. So I require a module which is called URL, and I can invoke a function parse, and I actually have full type hover on these things, and I know that if I pass the URL, there's a path name that's a string. Of course, the type flows, so I now know the file path is a string as well. So if I do things like file path is 1, it would actually tell me you should not do this. Generally, like, we don't mark these things as errors, but as warnings, because JavaScript people tend to do these things. So we want to be nice and say it's a warning, but allow you to configure this as an error or totally ignore it. So this is the one good thing. Of course, what you can also do now, and this might might raise a question how this works. So I can get HTTP and I get the full IntelliSense, right? So I say create server, I have my function, I have my request, my response, and like all of this is known. And this is beyond normal TypeScript usage. I know I'm writing TypeScript. And this is way beyond normal JavaScript. So what are we actually doing in the background? And so basically there's two types of operations that you can do with code. The one is the syntax operations like formatting and outlining. And the other thing is the semantics. And we actually help a little bit TypeScript with this by just rewriting the code behind the scenes. And I have a little playground for this. So let me copy this code and paste it in here. So this is a very bare down 2 types Monaco thing. And what it does, on the left-hand side, it accepts JavaScript. And on the right-hand side, it will spit out TypeScript code that we internally generate for this. So it's the reverse playground with like bells and whistles. So how we work how Monaco works internally, we always have the document, which is like the thing that you're currently editing. And all the heavy lifting work happens in web workers. So, you don't want to block the UI thread. You want to be a nice citizen. So all the documents, they have a mirror document, which lives in the worker, and we incrementally update it. And from this mirror document, I sort of like create another mirror document, which is rewritten to help TypeScript. So if I paste my code in here, you can see many things. So you will get compile errors here because I only have one file. I cannot resolve the DTS file. But you can see, so this looks very similar to all of this. So nothing changed here. But then you can see there's all these things above. So I do just quickly insert TypeScript statements, like proper TypeScript require statements with this very funky variable name. And then I just assign the original variable to whatever module I just have imported. And doing that, the type is being fetched from here. Actually, it's defined in the DTAs. Then I fetch it from here, and then it just flows with the variable, and then I can just use it as if I would have this way, right? So it's a very simple and cheap trick that we can do to enable these things. And all of this code always happens in, we call it a semantic language service. So this never goes back to the user. We are like pyramids of bugs where, where all these variables would show up, the fake variables that we generate would show up, but we try to fix them all. Sure. Yeah, that's a good question. Yeah, so this is the limitation, right? So all of these things only work because the types flow, right? So from here, the types do not flow to here because this request is just a parameter. It does work. Let me jump back to the other sample. So this one is just broken. This one doesn't know it. But if I rewrite my code into something nicer, and we have camel case matching here. So if I say request response, then of course, because the DTS file is very well, I can actually say, request URL, I know this is a string, and then I can do string math. So yeah, this is the limitation, and this is why there's a good reason for type annotations. But if you write your code in a certain way, which we often do with some libraries, you do get these things for free, right? So let me bring up another file, which is our main JS file, which is sort of just the rendering. So in here I use jQuery, right? And for jQuery, and similar to Knockout, you always have these global entry points, right? You can always say $, and now I already have jQuery, and so now I could say document. I get that. I say body, and then I can say CSS. Like I get the parameter hits, I know all the overloads, and then I can say background. Now if I rerun the Chuck Norris fact generator, like we have a blue background. So this is like helping me a lot, and like I have like these things, like you have a little typo, and then we tell you there's something wrong, right? This doesn't exist. The same is true if you put, like, if you are not sticking to the type signature, it will warn you. This is probably actually allowed because jQuery is very rich. Yeah, but definitely you always need a global entry point. If you cannot expect that the types just happen to be there magically. Oh yeah, definitely. So this is where this is the interesting this is the tipping point, because what we do is sort of like you would not design a system up front to based on code rewriting. You would sort of say, oh, I fork the TypeScript compiler and just make it understand a little bit more, right? And but we're like in time depression, then we just took this approach, and you can get a very far way with it actually. So the one demo, if you see my server.js file, you could see basically what I do. I always use modules that are defined in Node.js. So if I open that file, then you can see there's like many modules being defined, and then there's like HTTP, and this is actually declared modules. So I'm not using my own code. I'm just using environment code. If I look at the main.js, it's actually different, because this guy is the AMD module, as you would write AMD if you would do AMD, not TypeScript. And this one requests the facts file, which is another JavaScript file in the same folder. And with some magic rewrite tricks, we can also offer you IntelliSense on this guy, right? So if you go, we have IntelliSense, and I can also navigate to code. So I can say go to definition, and now this is like a typical way of writing AMD modules. You say define function. This one has no dependencies, and it returns an object literal, right? So if I take that code, you can also see what rewrite tricks we do there, because now it gets a little bit more interesting. So you can see I sort of keep the function call intact. The only thing I do, I redefine it. So in case it exports something, I can say export equal whatever this function was. And for every entry in this array, I generate an import statement. And then in this callback, I just say, yeah, the fact parameter, by the way, is the type of whatever you have imported. And this makes the types flow very nicely, just by the fact of me writing this. Very similar as if I would now say in here, return foo equals true, right? Then because this function returns an object literal foo, and it's defined as the generic t, the variable one, you can already see is a nice object foo boolean. So by just applying many TypeScript tricks, we could get a very long way. And then there's there's more IntelliSense things, but basically it's we should talk a little bit more about limitations. And this is you always need this global entry point to get to something. And from then on, once you have the types, they flow nicely. This is a jQuery element, so I can do this and all these things. Also, once you have the types and the type information, I can now say, oh, I rename this into an element, right? Or I can do very limited reference search, for instance, on this guy, say what are the references, so I can see where it's defined and where it's being used, right? So once you're on the happy path, you get quite good JavaScript tooling. If you leave it, you should go back to TypeScript. And that's most of it. So if you have more questions, please go ahead.
Just ask your question. If you can't hear, I'll repeat.
Is there a way, with a function handler, where you needed to inline the function, otherwise you don't get it processed? Is there a way to annotate a type, with a triple comment or
Did you hear the question?
I think so. So the question is if I can somehow like make the types appear here.
Yes.
Well, in theory, what you can do, you could just type the type in line, right? You can say, you will get like a hint, like it will tell you don't do this because this is TypeScript. But now TypeScript will know, right? TypeScript will now say, oh, request bang. The problem is now this is not valid JavaScript anymore. You cannot run it, right? So this might help you to code, but before you run it, you must remove these things. So that's not a good hint. Like, but that's,
so the short answer is it's not possible, right?
it's not possible. It's a short answer. Yeah.
So any other quick questions before we move on?
It is interesting to speculate, though, about what we could do around stuff like that. Allow you to put a comment there. I mean, it ends up being turning into closure, I guess, or something like it. But
in JavaScript, language service and Visual Studio, what we do is we use XML comments to infer to guide the types of these things.
Yeah.
It hasn't been widely used though, but it is another way of telling the system of the types.
Yeah.
But I think the Visual Studio XML comments, they only work for function declarations.
No, they work functions, variables.
Right, but like within a function, can you do a variable?
Yeah, inside the function, you can, or above a variable, you can just like / variable var, and then you give it a type.
Yeah.
There's definitely, we should make sure to connect these guys with the JavaScript team. I mean, I'm sure you guys already talked, but yeah, there's definitely some reusable ideas here.
So I think we have one more quick question, then we need to move on.
Yeah, sorry. So as a practical user, does this work in the HTML file, and do you support external references to web?
Sorry, I didn't get that question.
Does this work in the HTML file, and can I use external references?
So like my index HTML, of course, sets all of these up, and just like a thing that we support in Monaco. So we do support nesting. And like by default, a script tag is JavaScript. So now it will tell you that I have a require function, and somehow it doesn't know the config thing because that's maybe not in this DTS file. But I can this is now HTML embedded TypeScript, embedded JavaScript, and I can do all the tricks. So I can type AE in here and the same demo that we've seen before, right? It's just a little cooler here. Yeah. Yeah, definitely you can do it. Yeah, though there's a few bugs. Sort of like we introduced this, and it still has a few hiccups, but generally this is possible. Yeah.
It's very cool stuff.
Cool. Thank you.
All right. Okay. So thank you guys. Sorry about all the hiccups, and thank you for being up at 1 a.m. to show all this stuff to us. So
that's great. Thanks for the invitation.
Yeah, no problem. So let's switch laptops real quick. And we'll get Alexander from Skype going here.
I'll be talking about a framework that we developed while working on one of the tools for Skype that we use in Skype. Skype is not just the UI that you see while you're talking to your friends, but there's a lot of systems on the back end, and we're developing one of such systems. It's an A/B testing platform called ECS, Experimentation and Configuration Service. I want to tell you the history of the story of me, so to speak. I started working on UIs in the late 80s while I was in high school, and by about 91, I had a clone of the Microsoft UI library that Microsoft used in its own products, such as Quick Basic or Quick C, that kind of stuff. I decided to duplicate the Microsoft version because the Borland, in my opinion, wasn't just there. It was inferior to Microsoft. I also developed about that time a graphical library, for graphical buttons and that kind of stuff. Windows back then was just one of the graphical shells that were available on the market. It was not clear where things would go. In the mid and late 90s, I was a big fan of Delphi. And and so I think Delphi is still, by now, to me, is a holy grail of how develop environment for UIs should look like. And then in the early 2000s, I started working on web UIs. And to me, that was it was a tough change in the sense that I hated things like JSP. That just wasn't my, it was a downgrade to what I was used to as UI capabilities were available to me. And I resisted adopting JavaScript as a language that I would write in. I was working at that time at Hewlett-Packard, where we were working on a UI framework, where the UI, the DOM tree, would be generated on the server, and then would be transferred to the client, where any user events, such as mouse clicks, would be caught and sent back to the server, where they would be where they would be processed, and then a diff between the DOM on the server and the last DOM that we got from the client would be generated, and the diff would be sent back to the client. That was a good alternative to dealing with JavaScript. So as soon as a wonderful tool called Google Web Toolkit became available, I started using that, and that was much better too. That was really like, now I can use JavaScript because I would use Java and JavaScript would be generated. That's what I was used to. And also the kind of the UI framework that they had, they built in the stock JDBT library was also similar in concepts to Java Swing, or even going back to Delphi. Perhaps there was a lot of similarity. So that was fun. But and then I joined Microsoft. Skipping a few steps, I joined Microsoft in late 2013, and I needed to write this UI, and I needed to investigate what we can use as a platform. I'm glad I came across TypeScript. I immediately fell in love with it. So I decided that, yes, I want to use TypeScript, but what about the widget library? What about the UI library? And I investigated how we can integrate, for example, ext.js with TypeScript. I investigated Kendo.js. And what I found is that problem is that those big UI libraries for JavaScript, they implement their own version of inheritance. Take, for example, ext.js, and that doesn't play well with TypeScript. So we needed something more elegant, something that looks good in TypeScript. This slide just says that what I want to do is a pure JavaScript app. I've talked about that. I dislike all that templating approach, and so what we decided to do is we decided to take Kendo.js, its widgets basically, and wrap them with TypeScript, and that would look more or less okay. Well, time went by, and what started as just wrappers turned into more or less a UI framework. So the features that we have is it's an extensible widget library in the sense that you can take a class, let's say a button, you can subclass it, and you can override certain methods, and you can add your own behavior. We implemented our own version of MVC, which works for a single-page app and uses the hashtag for history management. If anybody is interested, I can tell more about that. We also implemented our own integration with the backend. We implemented object-oriented action dispatcher framework, where we take an action as an object, and we send it to the server, where it gets deserialized, gets processed, the result gets sent back as another object, and it also gets serialized. Let me show you. So this shows how our action dispatch works. Our server is in C#, and that was kind of a limitation of the environment that we had. So one of the issues that actually I'd be interested in is interoperability between TypeScript and .NET. Because what we have to do is we have to kind of keep two copies of action and model classes. One is the TypeScript version, and the one is the C# version. And we have to do tricky serialization, deserialization of those. And that kind of works. So go back though to what we have. We have forms and different kinds of input fields, all your drop downs and etc. Grids, and the grids and lists we took from Kendo. And we actually, the further we go, we're actually phasing Kendo out because we're finding that Kendo has too many hard-coded limitations that we're just struggling with. But it gave us a good head start. And we use strictly CSS-based styling. So let me do a demo, maybe show what I'm talking about.
So you said CSS-based stylings. Is it CSS or less?
We use CSS at this point, and we will use less, I'm sure. So this is the UI that we developed using completely using TypeScript, and we use this is inline editing. This is where our focus was. Our focus was on inline editing, so we can have the same version of the view for viewing and editing. So you can click on things and you can just edit it. This seemingly like just a text, right? But you click on it and it turns into editing. And this is where pure JavaScript apps shine, because you don't need to worry about what goes behind the scenes in the DOM. So let me do another demo, which is Hello World. So this is how a Hello World app would look like. We create a new root panel, and we create a new HTML Hello World. Let me show you where. So I had that page already open. I just need to refresh it. And I see Hello World. What happens is the page, when the page was generated originally, the body is just empty. And when we create a root panel, we create a widget that represents the body. So when we add a HTML widget in it, we effectively put a div inside that body. We can also do things like new vPanel. This is one of our layouts, and we put under it you put a new button. So now, if we refresh it, we should see the button. So I can make this more and more complex, but since I have limited time, I wanted to show how our MVC works. So I did a little trick that I sometimes used when I was a student to hide. When I was a student, just since it's a social event, we used to write assembly language programs. But we wrote them in Turbo Pascal using the awesome keyword. So what some guys did is they didn't want to deal with this assembler stuff. So they would put a go-to statement somewhere where it's not visible in the editor, and some Pascal code underneath that did the same thing. It actually worked. So I use this. And so what we do is we create a new controller. And we create a new a container would be new root panel, same root panel, and we would create we would say go to, and new view 1. So I just instantiated a controller that would put its contents inside the root panel, and the initial view that it would display would be view 1. And I also have a little CSS that colors this view differently. So the first view is yellow, and another one is bluish color. So when I click the button, it goes to the second view. Let me go back to the code. So the view 1, the way it's implemented, it's a show method. It has a show method where it generates a vPanel, HTML, the button, and it also has an on-click handler where it goes to, tells the presenter to go to view 2. So I have to admit that since I'm coming from the GWT background, this is how they do things in GWT, almost. In GWT, they call it MVP, Model View Presenter. So this is their take on MVC, how MVC should work in single-page apps.
Is this getting pushed on the history stacks or using like push
Yes,
or something?
yes. I don't have too much time, but we have a use history method and blah blah blah. It will do the thing. So you just need to provide mapping between history tokens and your views.
Right. So everything here is like fluent style then.
Yes. So another thing to mention, we use the so-called builder design, the builder pattern for widgets. So you can really chain method calls. The idea is to use declarative, declarative programming as much as possible. And since I only have a few minutes, I guess I'll just open it for questions.
Questions?
Yes.
What do you use for model? I mean, to exchange between the presenter and the actual data.
Okay, I'll give you an example. We simply use TypeScript objects. So this is our model class, and this is how it looks like. These are plain old TypeScript objects.
I guess what I'm asking is there any data binding support?
Data binding. Oh, I'm sorry. So that's the model you're asking. Yes, we support data binding, and we support for forms. We support only a one-direction data binding, meaning that when a field changes, we update the model. But when the model changes, we don't update the field. And because bidirectional data binding is too complicated, we try to keep things simple, and we get away with it. Another thing I just want to mention, so this is an internal project. It's not shared anywhere. It's not open source. We created this out of necessity because there were no good open source frameworks available for TypeScript. We are looking for collaboration to come up with a better, solid framework for TypeScript within Microsoft, outside of Microsoft.
Is this on CodeBox at least?
It's nowhere. No, it's just in our internal GitHub repository in Skype. And when I say I'm from Skype, Skype uses all kinds of technologies, anywhere from PHP to WebJS. And there's a whole range. And there's a Skype.com is developing their own JavaScript library. When I have a chance, when I meet other teams, I evangelize TypeScript, tell them all good benefits of it. Just again hoping to move this direction forward in terms of a UI framework.
It seems like there's a lot of use of TypeScript with Angular out there. Have you guys can you compare and contrast that, or have you looked at any of that, or?
Angular. Well, Angular is just. I am not a big fan of Angular because Angular is developed for people who use the templating approach. You have an HTML page and you put Angular, type stuff in it. We don't need that. We don't have the problem. We have a pure JavaScript application.
Can you do ext in this though? Why can't those specific? ext is so much better.
Yes, I've mentioned why we don't use ext. ext is a behemoth. In fact, when I tried to integrate ext with TypeScript 0.9.5, it didn't want to work. It crashed inside Visual Studio. That's how huge ext is. You can really tell if you see an ext-made app, you can really tell right away because there's so much proprietary hard-coded style, and it's really hard to really override it. So, yeah, we looked at it. We decided not to.
Right. Okay.
Okay.
We need to move on to give Jason time. We're starting to come
Thank you.
to his, but thank you very much. I would get it on CodeBox and then send out pointers to the TypeScript and JavaScript classes.
So I'm Jason He. I'm a dev lead from GFS, Global Foundation Service Team. So Global Foundation Service Team manages Microsoft data centers. So for people from product team may not be familiar with that, but people work on cloud, they know GFS. So our team builds tools for GFS. For my team, we build asset management tools and supply chain management tools. So today I'm going to present Today I'm going to present the jLib framework. This is the framework we created to support our internal solutions. So for this framework, we're trying to create a kind of Silverlight type of programming experience using TypeScript. So we have things like XAML kind of syntax support. We support data binding. We can do MVVM pattern, and we have our own reusable control libraries. And for our internal solution, we have a huge dependency on OData services. All our backend are OData services. So we create a function to generate service reference, just like WCF. Then we added a link to OData support in our framework. So this is our major solution, and basically we allow people to basically build queries to find assets in the system, and we can basically find details for assets. And those are just, I'm not going to do a detail for our solution just to save time. And we can do other visualization work. Like, for example, this is the new one we are building for, hold on. Building for our data centers to show our colos inside data center. And you can see the racks are loading. While we're loading, we're actually talking to the backend to talk to our OData service to grab the information for the racks, and server here's the rack information, and you can see a little bit detail in the rack. This part of this rack is empty. Let me see another one.
I don't think there's any devices. Oh,
really?
Zero used. Not yet.
Okay. Let me see. Yeah, those are the devices in the rack, and you can even go to see individual device and find even more details there. So I'm not going to go to the details there. And the next one, I want to show you how we organize our code. So for us, we create this jLib framework. Basically, it's a library. It has a bunch of control libraries, and we try to mimic the .NET framework follow the namespace convention here. So, and for common libraries and the control libraries, then with that we actually can use that in our code. So, for example, this MSS set is our solution, and we use MVVM coding pattern. For example, we can create views. For example, this is one module. This change history is one module we developed. We have many modules. And to build a view, we basically try to use XAML kind of syntax. And you can see that we call it XAML because XAML actually have a default designer, which doesn't match our design. We are essentially behind the scene. We still use CSS. So we can define the YAML as the view, and we have the code behind, which basically is written completely in TypeScript to basically link the view and the JavaScript on the browser. And all our modules have this view and view model, view and code behind for the view, and we also have the view model for the data binding. For MVVM, there's another piece is called model, right, which basically represent the data. Basically, in our case, will be services. And so we have a model folder. Here we generate this is about 10,000 lines of code we automatically generate, basically by looking at our data metadata. And I'll show you later and how to generate that. We have a tool. The tool is also written in TypeScript. And with that, we basically automatically generate model. We create a view model on top of that. Then we use the XAML syntax to create view. So that completes our MVVM story.
So do you have like some sort of like pre-compiler for the views that?
It's runtime. I'll show you the detail. So let me start from actually, let's just use this project. Let's start from Hello World. So this is Hello World. Basically, we load our framework, make one functional call, and jLib.js is our TypeScript library, basically the jLib framework itself. And the whole body basically loads another YAML. And the YAML is like basically like XAML. We have a stack panel inside it. We have tags and a button. And that's pretty much what we have. And then for the view, basically say button click as send click. For this, and basically I can just run it. So that's for the button click. And the next one I want to show you is let's say I change to simple binding. You see, and I only really specify the YAML file. And in this case, I got a different YAML file. Basically, it's a text box. I have two bindings. One binding binds to the text. Another binding binds to the color. So in the code behind, I basically say, hey, I create a model which has only one color field, which is a bindable property. I will set that as data context for my text box. So with that, I can run it. Basically, it's a text box. But the thing is, I can now basically say, I can say red, then it's red. Because the binding sends two-way notification, and our binding are always two-way. You just don't send to itself, but it's always two-way. Another example, say, this is a little bit more complex data binding scenario. So I have a slider. I can just basically drag drop there, and it sends notification to multiple objects. And if we take a look at the code behind, is just a different XAML. You have slider control, shapeboard control, rectangle, circle, text, and they all have binding to size. And the code behind looks like this. Basically, I have one data model to bind it, and they have only one size property, which is a bindable property. And we also see, so this is another one, say is HTML content. I'll have to ignore this for now. So here is basically we have a control. The control actually can host HTML inside it. And we also support, say, hybrid mode. Basically, you can say you have HTML, but you have a div, which basically say, I want to load the YAML. This could work as well. So let me see any other things. The next one I want to show you is a different project.
We have about 5 minutes.
Yeah, okay. So this is a application I built just for demo. Did I run? I want to demo the OData piece. So, for example, I can go to Northwind to get data, basically get data from cloud and display that in our solution. And what I want to show is really the UI is really simple, less than 30 lines of code, the markups. So I have all the navigation panel, and essentially it's a data grid. And the code makes it work for all kinds of scenario is also very short, less than, say, 70 lines of code. And since we're using the model from the proxy, we got IntelliSense, link, all those support. So for example, I can do things like here, basically say, I have one called IP. We have IP address. Say I can do expansion on that. And I say, hey, my expansion will expansion to reservation object. Then I can say, hey, I give a where clause. Say my name will contain something like I want 10. The IP started from 10. Like something like this. Then I run it again. It's running.
This is not using the new compiler, obviously.
No, it's old compiler. So now I'm sending requests using the link syntax. So the name all starts from 10 dot something.
Awesome.
Yeah. So we have this proxy support. Let me show you one last thing. So we built a portal basically just for demo purpose. We use that for our hackathon project. So you can see there. So to do proxy generation, we talked about is you basically can paste metadata here that will generate proxies. For example, for Northwind, we just select Northwind. Say I want to generate that. So we're going to the cloud, ask Northwind to get their metadata. Then we generate the code. Basically, copy paste code, put that as our model. So that's how we basically interact with our OData service. And this demo set has a lot of controls. For example, you have list view, right? And you can see from the markup, and we have list view, and list view for each item. We have item template. Each item template is a data template, just very similar to Silverlight.pf. And the code behind basically just set the data model there. And there are other things like, say for example, you have calendar control, right? Like if I want to say I know people don't want to copy paste. Let me try just once. So I've got another calendar. Let me update. Then we got two calendars. So this basically the markup is dynamically translated into JavaScript, and the HTML object will be created dynamically. And we also have a unit test framework for that. So for example, for our jLib, we have a bunch of unit tests, and we create this way we can host the unit test. Say I want to run all the unit tests, I just basically say run, then they start to load that. Because our unit tests follow certain class conventions, then we got that. So I'll wrap up here and just complete the slides. So we demoed those scenarios, and one thing I want to highlight, our data binding syntax is much simpler than the current Silverlight version because we use this bindable property. We basically hide the notification part inside the framework so that we can, from user perspective, they don't really need to write that code. Also, for the OData custom action, we can generate proxy just like a method. But right now in our application, when we using the .NET proxy to talk to OData service, we actually need to write a little bit more complex code there. And we talk about markups and the data templates. Basically, our data templates allow us to basically specify how each item will be rendered. And in the last will be a few information for you guys to take a look. So I will write
that's on CodeBox. That's good.
Yeah. Okay. That's all.
Okay. Awesome. Any quick questions? No questions? All right. Well, thanks a lot, Jason. Okay, and I guess for, I don't know, maybe a year or whatever we can get back together next after you guys finish your compiler, right? That's it for the meetup. I'd like to thank all the speakers and everyone that took part and our admin assistant that actually did all the work. I just showed up.
Thanks to Steve.
Yeah, thanks. All right. Well, thanks.